The morning of September 19th, 1944, a farmhouse near Réchicourt-la-Petite, France. Sergeant James Stacy gripped the controls of his M18 Hellcat, feeling the engine purr beneath him like a caged animal waiting to be unleashed. Through the thick grey fog that blanketed the Lorraine countryside, he could barely see 20 yards ahead, but he could hear something, the deep, grinding rumble of heavy machinery cutting through the morning stillness. German armour, close, very close. His loader, Private First Class Miller, whispered what they were all thinking. That's got to be Panthers. Nothing else sounds like that. Every tanker knew that sound, the distinctive growl of a Maybach engine pushing 45 tons of German steel, the most feared tank on the Western Front, a machine built to dominate the battlefield with thick sloped armour and a gun that could punch through anything the Allies fielded. Then the fog shifted, just for a moment, and there it was. The long barrel of a 75mm gun emerged from the mist like a phantom, followed by the angular hull of a Panther. Stacy's heart hammered in his chest, but his hands stayed steady. This was the moment they'd trained for. This was why the M18 existed, not to slug it out face to face with German heavy armour, but to do something the Panthers couldn't possibly expect, something that broke every rule of armoured warfare the Germans had ever written. Stacy gave the order. The Hellcat's engine roared from idle to full throttle in an instant. The vehicle surged forward, accelerating with a violence that threw the crew back in their seats. 20 miles per hour, 30, 40. In seconds, they were flanking the German position, moving so fast the Panther crew didn't even have time to react. The German gunner was still trying to traverse his turret when Stacy's gunner fired. One shot, clean through the Panther's thin side armour. The German tank erupted in flames. Before the smoke even cleared, Stacy was already reversing at 25 miles per hour, disappearing back into the fog. The whole engagement had lasted less than 30 seconds. Somewhere in that burning Panther, a German tank commander was learning a brutal lesson. Speed wasn't just an advantage. In the hands of the right crew, with the right machine, speed was a weapon more deadly than any gun. This wasn't how tank warfare was supposed to work. German doctrine, Soviet doctrine, British doctrine, they all agreed on the fundamentals. Thick armour protects you. Big guns kill the enemy. You find a strong position, you hold it, and you trade blows until someone breaks. But the Americans had arrived in Europe with a different idea entirely. An idea so radical, so seemingly reckless, that German intelligence officers had actually laughed when they first read the specifications. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The M18 Hellcat was born from a simple question that sounded like madness to every traditional armour officer. What if we stopped trying to build better tanks and instead built something that could simply refuse to be where the enemy was shooting? What if survival didn't come from thicker steel, but from never getting hit in the first place? The man who asked this question was Lieutenant Colonel Andrew Davis Bruce, and in 1941 he was looking at the German Blitzkrieg victories and seeing something everyone else had missed. While Allied commanders obsessed over the Panther's thick frontal armour and the Tiger's intimidating 88mm gun, Bruce focused on something else entirely. The German doctrine required their armour to advance, hold ground, and anchor breakthrough operations, which meant German tanks had to be where the fighting was. They had to stand and deliver. Bruce realised that if you built a Darlight vehicle that never had to stand still, you could turn that doctrine into a fatal weakness. So, he gave the engineers at Buick a challenge that sounded impossible. Take the same Continental R 975 radial engine that powered the 30-ton Sherman tank, put it in a chassis that weighed barely 18 tons, give it enough firepower to kill a Panther from the flank, and make it fast enough that German gunners would never get a clean shot. The result was something the world had never seen before. A tracked vehicle that could hit 55 miles per hour on a road. A tank destroyer that could accelerate from standstill to 30 miles per hour faster than a Panther could rotate its turret. The Germans built their Panthers to weigh 45 tons, with armor thick enough to shrug off frontal hits from most Allied guns. Their designers obsessed over every millimeter of steel plate, 80 millimeters on the frontal glacis, angled at 55 degrees, 100 millimeters on the turret front, side armor 40 millimeters thick. It was a mobile fortress, designed by engineers who believed that survivability came from being able to take a hit and keep fighting. The Panther embodied a philosophy as old as armored warfare itself. Be strong enough to absorb punishment, hit hard enough to destroy anything that threatens you. Hold your ground and win through superior firepower and protection. The M18 Hellcat designers looked at that same problem and reached the opposite conclusion. Their armor was barely half an inch thick in most places. A good rifle-caliber machine gun could punch through it at close range. The turret was open-topped, leaving the crew exposed to artillery fragments and hand grenades. By every traditional measure, the Hellcat was a death trap. German intelligence analysts who examined captured Hellcats couldn't believe the Americans were serious. 40 millimeters of armor against Panthers and Tigers? It was suicide. But here's what those analysts missed. The Hellcat wasn't designed to absorb hits. It was designed to never be there when the shells arrived. Every ton of armor the Germans added to make their Panthers survive longer made them slower, less maneuverable, harder to maintain. The M18's designers threw away protection and bet everything on a different kind of survival. Be faster than the enemy can react, hit from angles they can't defend, disappear before they can coordinate a response. This created two fundamentally different machines. The Panther's massive Maybach engine produced 690 horsepower, but had to push 45 tons of steel. The Hellcat's Continental engine produced 450 horsepower, but only had to move 18 tons. The power-to-weight ratio was revolutionary, 25 horsepower per ton, compared to the Panther's 15. On paper, the Panther could reach 55 kilometers per hour. In practice, British testing showed it struggled to hit 30 miles per hour, and its transmission was so delicate that aggressive driving often led to mechanical failure. The Hellcat could sustain 40 miles per hour across rough terrain that would shake a Panther apart. Its Torquematic automatic transmission meant the driver never had to take his hands off the controls to shift gears during combat. While Panther drivers had to carefully manage their temperamental manual transmissions, Hellcat drivers could focus entirely on maneuvering. More importantly, the Hellcat could reverse at 25 miles per hour. Think about that. Most tanks of the era could barely manage 5 to 10 miles per hour in reverse. The Germans designed their Panthers to advance and hold. Retreating quickly wasn't part of the doctrine. The Americans designed the Hellcat to strike and vanish. Fast reverse speed was just as important as forward acceleration. The real genius, though, was in the details. The Hellcat's turret could complete a full 360-degree rotation in 15 seconds. The Panther's much heavier turret, packed with thick armor, took 20 seconds or more. In tank combat, those 5 seconds were an eternity. By the time a Panther commander realized where the threat was coming from and got his gun pointed in that direction, the Hellcat had already fired, relocated, and was lining up another shot from a completely different angle. The 76mm gun on the Hellcat was identical to the one mounted on later model Shermans. It couldn't penetrate a Panther's frontal armor at normal combat ranges, but it didn't need to. The Hellcat's entire tactical doctrine was built around never facing a Panther head-on. Flanking shots into the Panther's 40mm side armor, the Hellcat's gun punched through like paper. Rear shots into the engine compartment, catastrophic damage every time. The Americans had done the math. If you can't outmuscle the enemy, outthink them. Force them to fight on your terms, not theirs. This philosophy extended into every aspect of the vehicle. The open-top turret that seemed like such a vulnerability actually provided superior situational awareness. Hellcat commanders could see more, react faster, and escape more quickly if their vehicle was hit. The crew could load ammunition faster without the confined space of a closed turret. In hot weather, They didn't suffer the brutal conditions inside sealed German tanks. The thin armour meant faster production times. Buick could build Hellcats at a fraction of the cost and time required for a Panther. America could afford to lose them in combat. Germany could not afford to lose Panthers. But the most important difference wasn't mechanical, it was psychological. German tank doctrine assumed that armour battles were decided by who had the better tank. Superior engineering would triumph over inferior numbers. It was a deeply ingrained belief, forged in the victories of 1940 and 1941, when German armour had swept across Europe. The Panther was supposed to restore that superiority after the shock of encountering Soviet T-34 seconds. Every aspect of its design reflected the German conviction that quality and protection would overcome any disadvantage. The American tank destroyer doctrine rejected that assumption entirely. Battles weren't won by having the best vehicle. They were won by combined arms coordination, superior intelligence, faster decision-making, and the willingness to trade traditional advantages for unexpected capabilities. The Hellcat crews were trained to think like guerrilla fighters, not knights in armoured duels. Hit hard, hit fast, disappear. Don't hold ground. Don't trade blows. Control the terms of engagement and refuse to fight fair. This meant the Hellcat worked best when it operated as part of a team. American doctrine called for tank destroyer battalions to remain concentrated, ready to rapidly deploy against enemy armour breakthroughs. In practice, Hellcats were often distributed among infantry and divisions, providing mobile fire support. But when they were used as intended, multiple platoons coordinating to ambush and overwhelm German armour formations, the results were devastating. The Germans would find themselves facing threats from multiple directions simultaneously, unable to concentrate their fire, unable to leverage their superior armour and firepower. What made the Hellcat particularly effective was American radio communication. Every Hellcat had a radio. Platoons could coordinate in real time, calling out targets, sharing intelligence, setting up crossfires. German Panthers, by contrast, often had only one radio per platoon. Individual tanks communicated with flags and hand signals. In the fog of battle, this meant German tankers fought as individuals, while American crews fought as an interconnected network. When 4 Hellcats coordinated an ambush, they weren't 4 separate vehicles. They were a single deadly organism with multiple sets of eyes and guns. The irony was that German military theorists had pioneered the concept of combined arms maneuver warfare. The Blitzkrieg victories relied on coordination between tanks, infantry, artillery, and air power. But by 1944, German armour doctrine had become rigid and predictable. Panthers were deployed to hold key terrain, anchor defensive lines, spearhead counterattacks. The Americans could read German intentions because German doctrine was so consistent. Where Panthers appeared, their mission was obvious. Hellcats, on the other hand, were unpredictable. They might provide infantry support one day, screen and advance the next, set up defensive ambushes the third day, or race 50 miles to reinforce a threatened sector. Their speed and flexibility made them far more difficult to counter. German commanders never knew where Hellcats would appear or how they would be used. This uncertainty was itself a weapon. It forced the Germans to be cautious, to move more slowly, to hold back reserves. They couldn't afford to commit. So, when Sergeant Stacy's Hellcat emerged from that fog near Rechicourt on September 19, 1944, it wasn't just one fast tank surprising a slower one. It was the collision of 2 completely different philosophies about how wars are won. The Germans believed in engineering excellence, superior protection, and methodical execution. The Americans believed in adaptability, calculated risk, and the willingness to sacrifice conventional advantages for decisive speed. Over the next 3 days, the Battle of Aricourt would prove which philosophy was right, and for the German tankers of the 113th Panzer Brigade, that lesson would be written in burning steel. The 704th Tank Destroyer Battalion had arrived in France in late July of 1944. They were part of Lieutenant General George Patton's Third Army, and they'd been attached to the 4th Armoured Division, one of the finest American armored formations in Europe. The men of the 704th had trained extensively on the M18, learning its strengths and limitations through countless exercises. They knew their vehicles couldn't take a hit, so they practiced not being there to get hit. Lieutenant Edwin Leiper commanded one of the Hellcat platoons in Company C. On the morning of September 19th, his 4 M18s were positioned on Hill 246, overlooking the approaches to Aracourt. The fog that morning was so thick you could barely see your hand in front of your face. Visibility was down to maybe 30 yards. For most tank units, that fog would have been a nightmare. You couldn't see threats. You couldn't coordinate movement. You were blind and vulnerable. But for Hellcat crews, fog was an opportunity. Captain William Dwight had positioned Leiper's platoon in a slight depression at the crest of the hill, hull down with good sight lines to the valley below. Multiple escape routes were already planned. They had radio contact with other American units. And they were waiting. At 7:45 in the morning, the first German tank emerged from the woods at the base of the hill. Sergeant Stacy, commanding the lead Hellcat, didn't hesitate. One shot. The German tank, later identified as a Panther, erupted in flames. More shapes appeared in the fog, the distinctive silhouettes of Panthers, advancing in column formation, classic German tactics, moving methodically, expecting to encounter defensive positions they could destroy with superior firepower. They had no idea they were walking into a killing ground. Stacy's Hellcat fired again, another Panther destroyed. But then, a German gunner got lucky. A 75mm shell from a Panther struck Stacy's M18. The crew was injured, but the vehicle could still move under its own power. Stacy reversed at full speed, disappearing back toward Aracourt to get medical attention. The other 3 Hellcats in Leiper's platoon immediately repositioned, not retreating, relocating. They moved to new firing positions along the hill, forcing the Germans to search for them again. The Panthers tried to advance, but every time they moved, another Hellcat appeared from a different angle, fired a killing shot, and vanished. The German formation started to break apart. Some Panthers tried to rush the hill. Bad decision. The Hellcat's speed advantage was even more pronounced going downhill than up. They could accelerate, fire, and reverse back over the crest before the Germans could respond. Other Panthers tried to hold their position and use their superior frontal armor. Also a mistake. The Hellcats simply went around them, using the terrain and fog to mask their movements. By 9 in the morning, when the fog finally started to lift, 5 Panthers were burning wrecks. The 704th had lost only Stacy's damaged Hellcat, and even that vehicle was repairable. But that was just the opening act. As the fog cleared, the full scope of the German attack became visible. Elements of the 113th Panzer Brigade, roughly 30 Panthers supported by infantry, were advancing toward Aracourt. They'd expected to overrun lightly defended American positions. Instead, they found themselves facing the entire 704th Tank Destroyer Battalion, plus Sherman tanks from the 37th Tank Battalion, plus American infantry with bazookas and anti-tank guns. The Germans were walking into a carefully prepared defense. Captain Tom Evans, commanding Company C of the 704th, orchestrated a masterful tactical maneuver. He sent 1 platoon of Hellcats forward as bait. These 4 M18s deliberately exposed themselves to the German formation, drawing fire and attention. The Panthers, seeing what looked like vulnerable American armor, focused their entire attention on this small group. German commanders ordered their tanks to engage these targets, thinking they could quickly eliminate them and continue the advance. They never saw the trap closing. 2 more platoons of Hellcats, 8 vehicles total, were quietly maneuvering around the German flanks. Using the rolling terrain of the Lorraine countryside, they approached from angles the Panthers couldn't defend. The German tanks were oriented forward, their thick frontal armor facing the American positions. Their 40mm side armor was completely exposed. Evans gave the order. 12 Hellcats opened fire simultaneously. The effect was catastrophic. German tank commanders found themselves under attack from 3 directions at once. Turrets tried to traverse to face the threats, but the Hellcat's superior rotation speed meant they were always a step behind. By the time a Panther had its gun pointed at where a Hellcat had been, that M18 was already relocating to a new position. The bait platoon, now free from German attention, added their firepower to the ambush. Panthers started burning one after another. The German infantry, advancing in support of their tanks, found themselves exposed and pinned down by American small arms fire. Without infantry protection, the Panthers were vulnerable to close assault. American soldiers with bazookas began working their way forward, targeting the already damaged German vehicles. The 113th Panzer Brigade's attack fell apart. Some Panthers tried to retreat. Others attempted to hold their ground and fight it out. Both choices proved fatal against an enemy that refused to stand still long enough to be targeted effectively. Sergeant Henry Hartmann, commanding a single M18, personally destroyed 6 German tanks that day. Most of them were Panthers, the supposedly invincible German medium tanks that had terrorized Allied forces since their introduction. Hartmann's tactics were textbook Hellcat doctrine: identify target, maneuver to the flank using speed and terrain, fire 2 or 3 shots maximum, relocate immediately before return fire arrives. Repeat. He never stayed in one position long enough for the Germans to coordinate a response. By noon on September 19th, the German attack had been completely shattered. The 704th Tank Destroyer Battalion had engaged and destroyed 15 Panthers in the morning fog alone. Over the next 3 days, as the Battle of Aracourt continued, the Americans would claim a total of 39 German tanks, destroyed mostly Panthers, while losing only 4 M18s destroyed and 3 damaged. The kill-to-loss ratio was nearly 10-1. These numbers weren't propaganda. They were verified by after-action reports, physical counts of destroyed vehicles, and even German records. The tactical lesson was clear. Speed and coordination could overcome armor and firepower, but the psychological damage to the Germans was even more profound than the material losses. The crews of the 113th Panzer Brigade were not inexperienced recruits. Many had fought on the Eastern Front. They'd faced Soviet T-34 seconds, which were excellent tanks in their own right. They'd learned to trust in their Panthers' superiority. The thick frontal armor could shrug off most Soviet guns. The long 75mm cannon could destroy T-34 seconds at ranges where the Soviet tanks couldn't effectively return fire. But the Hellcat didn't fight like a T-34. Soviet doctrine emphasized mass attacks, overwhelming numbers, accepting heavy casualties to achieve objectives. The Soviets built thousands of T-34 seconds and accepted that many would be destroyed. German tankers had grown accustomed to this pattern. They knew Soviet tanks would attack frontally. They knew they could usually achieve favorable kill ratios. The material losses were sustainable because German armor quality compensated for Soviet numbers. The Americans fought differently. They didn't accept casualties as inevitable. They used intelligence, coordination, and speed to minimize their own losses while maximizing enemy damage. A Hellcat crew would never charge a Panther head-on. That would be suicide and tactically pointless. Instead, they would use terrain, use fog, use their speed advantage to create situations where the Panther's strengths were irrelevant. Front armor doesn't matter if you're shooting at the side. Gun range doesn't matter if you're gone before they can aim. This created a profound sense of helplessness among German tankers. They were sitting in some of the most advanced tanks in the world, yet they couldn't bring their advantages to bear. It's one thing to be outgunned or outnumbered. Soldiers can accept that and still fight effectively. It's another thing entirely to feel like your enemy is playing by different rules, rules you don't understand and can't counter. The Hellcats created that feeling. German tank commanders started reporting that American light tanks, they often misidentified M18s, could appear and disappear like ghosts. After Aracourt, German armor doctrine began to change. General Hasso von Manteuffel, commanding the 5th Panzer Army, issued new orders to his tank units. These orders were a stunning admission of defeat. They read, Enemy tank destroyers of exceptional speed operating in this sector. Do not pursue. Do not engage in mobile battle. Read those words again. The commander of a Panzer army was telling his tank crews not to fight. He was instructing the masters of mobile armored warfare to avoid mobile engagements. The psychological impact cannot be overstated. For 5 years, German Panzer divisions had been the spearhead of German military power. From Poland to France to the Soviet Union, German armor doctrine had been about aggressive maneuver, about seizing the initiative, about using speed and shock to break through enemy lines. Now, facing an enemy that was faster, more flexible, and more willing to take risks, German commanders were ordering their troops to hunker down and defend. The Hellcat had broken something fundamental, not just German tanks, but German confidence. The Battle of the Bulge in December of 1944 provided another opportunity for Hellcats to prove their worth. When German forces launched their massive surprise offensive through the Ardennes forest, American lines were shattered. Entire divisions were cut off. The situation was desperate, but M18 battalions, including the 705th Tank Destroyer Battalion, were among the first units to respond. Their speed allowed them to reach critical positions, hours or even days ahead of heavier American armor. Team Desaubry, a combined task force built around Hellcats, made a high-speed run to defend the town of Neuville, just north of Bastogne. They arrived literally minutes ahead of German spearheads. For the first time in the war, the M18's 55-mile-per-hour top speed wasn't used for flanking maneuvers or hit-and-run attacks. It was used simply to outrun the Germans to a critical objective. Once there, the Hellcats used their usual tactics: ambush, relocate, ambush again to slow the German advance. Every hour they bought allowed American forces to reorganize and establish defensive lines. The engagements during the Bulge were particularly brutal because they often took place in confined forest roads where the Hellcat's speed advantage was limited. But even there, American crews found ways to adapt. They used their superior reverse speed to back up narrow roads faster than Panthers could advance. They set up ambushes at crossroads and used their quick turret traverse to engage multiple targets in rapid succession. When German forces tried to bypass defended towns, Hellcats raced along parallel roads to set up blocking positions ahead of them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The statistics tell the story. By the end of the war in Europe, the M18 Hellcat had achieved a kill-to-loss ratio of approximately 2.4 to 1. For every Hellcat lost in combat, American crews destroyed nearly 2.5 enemy armored vehicles. This was the highest kill ratio of any American tank or tank destroyer in World War II. It's a remarkable achievement, especially considering the Hellcat's thin armor and the fact that it was often used in roles it wasn't designed for, like direct infantry support. But numbers alone don't capture the full impact. The M18 cost approximately $57,000 to produce. A Panther cost over 117,000 Reichsmarks, roughly equivalent to $70,000, and required 55,000 man-hours to build. America could replace Hellcat losses faster than Germany could count them. Buick produced 2,507 M18s between July 1943 and October 1944. German factories struggled to produce 6,000 Panthers during the entire war, and many of those broke way down due to mechanical issues before they ever saw combat. The industrial mathematics were devastating for Germany. Even if Panthers achieved better kill ratios in individual engagements, which they often did against Sherman tanks, they couldn't win a war of attrition against American production capacity. The Hellcat made this worse because it specifically targeted German heavy armor, the expensive, difficult-to-replace vehicles that Germany had invested so heavily in. Every Panther destroyed by a cheap, rapidly produced Hellcat was a strategic victory that extended far beyond the tactical battlefield. The doctrinal implications were equally important. German armor doctrine required tanks to hold ground, anchor defensive lines, and spearhead counterattacks. This meant German tanks had to be where the fighting was. They had to stay engaged. The Hellcat doctrine was the opposite. Strike when you have the advantage, disengage when you don't. Never commit to a fight you're not confident you can win. This flexibility meant Hellcat battalions preserved their strength, while German Panzer units were slowly ground down in battles they couldn't afford to avoid. The human cost of this approach shouldn't be overlooked. Hellcat crews lived with constant vulnerability. They knew that any hit from a tank gun, an anti-tank gun, even heavy machine gun fire at close range could be catastrophic. The thin armour provided almost no protection. The open turret meant artillery fragments and grenades were constant threats. Crews developed superstitions and rituals to cope with the stress. Some refused to name their vehicles, believing it was bad luck. Others decorated them elaborately, a kind of whistling past the graveyard defiance. But they also developed an intense pride in their vehicles and their tactics. Hellcat crews saw themselves as the elite. They weren't sitting behind thick armour hoping to absorb punishment. They were actively outthinking and outmaneuvering the enemy. Every successful engagement reinforced their belief in the doctrine. Every time they struck a Panther from the flank and disappeared before the Germans could respond, they proved that skill and speed could triumph over brute force. This wasn't luck. It was professional competence, executed under the most stressful conditions imaginable. The Germans, for their part, never really developed an effective counter to Hellcat tactics. They tried deploying Panthers in pairs, covering each other's blind spots. This reduced their mobility and turned offensive weapons into static pillboxes. They tried using combined arms, with infantry screening for tanks, but American artillery and air power usually dispersed the infantry before they could be effective. They tried ambushing the Hellcats, but the Americans had better intelligence and rarely blundered into traps. The fundamental problem was that German doctrine was built around methodical, powerful advances that seized and held terrain. The Hellcat refused to hold terrain. It appeared, killed, and vanished. German tanks were optimized for frontal engagements at medium to long range. The Hellcat forced close-range engagements from the flank. German combined arms required coordinated movement by multiple unit types. The Hellcat's speed allowed it to isolate German tanks from their supporting infantry and artillery. No tactical adjustment could overcome these structural disadvantages. By the spring of 1945, as Allied forces pushed into Germany itself, Hellcat battalions had become one of the most feared American armoured units. German soldiers learned to recognise the distinctive engine sound and the low-slung silhouette. When Panthers and even Tiger tanks encountered Hellcats, German commanders often ordered withdrawals rather than risk engagement. The hunters had become the hunted. The machines designed to terrorise Allied armour were now running from a vehicle with half-inch armour and a gun that couldn't penetrate their frontal protection. The final statistics are worth contemplating. 526 confirmed kills in total, 498 in Europe, 17 in Italy, 11 in the Pacific. These numbers were achieved by a vehicle that cost less than a Sherman tank, required a fraction of the production time of a Panther, and could be maintained by mechanics with standard automotive tools. The M18 wasn't the most powerfully armed American vehicle. It wasn't the best protected. But it was, without question, the most effective tank destroyer America fielded in World War II. The legacy of the Hellcat extends far beyond its combat record. It represented a fundamental challenge to everything the military world thought it knew about armoured warfare. Since tanks first appeared on the battlefields of World War I, the trajectory had been clear. Tanks would get bigger, heavier, better protected, more powerfully armed. The French built massive heavy tanks in the 1920s. The Germans responded with the Tiger. The Soviets built the IS-2. Everyone assumed that firepower and protection would always trump mobility. The M18 Hellcat proved them wrong. It demonstrated that in the right hands, with the right doctrine, speed could be armour, manoeuvrability could be firepower. The ability to control when and where combat occurred could overcome any disadvantage in protection or gun caliber. This wasn't a theoretical insight. It was proven in hundreds of engagements across Europe, where Hellcat crews consistently outfought opponents in objectively superior vehicles. Modern military doctrine still grapples with the lessons of the Hellcat. The current American emphasis on rapid deployment, on avoiding prolonged engagements, on using superior intelligence and coordination to achieve objectives with minimal casualties. All of this traces back to World War II tank destroyer doctrine. The M1 Abrams tank, despite weighing 70 tons, emphasizes speed and situational awareness alongside its impressive firepower and protection. Israeli armored tactics in multiple wars have focused on speed and flanking maneuvers rather than head-on assaults. The ghost of the Hellcat haunts modern armored warfare, but perhaps the most important legacy is psychological. The Hellcat taught a generation of American soldiers that they didn't need to outmuscle the enemy. They needed to outsmart them. That technological sophistication alone wouldn't win wars. That the side willing to take calculated risks, willing to fight unconventionally, are willing to adapt doctrine to match capabilities rather than trying to match enemy strengths, that side had advantages no amount of steel and firepower could overcome. These lessons resonated far beyond tank warfare. They influenced American military thinking for decades. Immediately after the war ended, the US Army deactivated all tank destroyer battalions. The M18 was retired from American service, deemed obsolete in an era of nuclear weapons and Cold War confrontation. It seemed like an ignominious end for the vehicle with the best combat record of the war, but Hellcats continued serving with allied nations for decades. Yugoslavia operated M18s until the 1990s. Taiwan converted them into light tanks by mounting the turrets on different chassis, extending their service life into the 1980s. Greece used them well into the 1970s. These nations understood what the Hellcat really was. Not a temporary wartime expedient, but a vehicle that perfectly embodied the principle that cleverness and speed can overcome material disadvantages. For countries that couldn't afford to build massive armies of heavy tanks, the M18 offered an affordable way to field effective anti-armor capabilities. Its reliability, ease of maintenance, and effectiveness in the hands of well-trained crews made it valuable long after more advanced vehicles had been scrapped. The men who crewed Hellcats during World War II carried their experiences into civilian life. Many became leaders in business, education, and community service. They'd learned under fire that you don't need the biggest gun or the thickest armor to win. You need the clearest thinking, the fastest reaction, and the courage to commit to a plan even when it seems reckless. These weren't lessons learned from textbooks. They were lessons learned at 50 miles per hour, outrunning German shells, trusting your crew and your machine to do things that seemed impossible. Years after the war, veterans from both sides met at reunions in the places where they'd fought. At Aracourt, a restored M18 Hellcat was brought to one such gathering. When its engine roared to life, German veterans who'd fought there in 1944 stood silently, watching. One elderly German, who'd commanded a Panther during the battle, said simply, "We never had a chance. Not because German tanks were inferior, they weren't. Not because German crews lacked skill, they didn't. But because the Americans had written a different rulebook, and by the time German commanders understood what they were facing, the war was already lost." The Hellcat story is a reminder that wars are won by adaptation, not by adherence to doctrine. The Germans built magnificent machines based on theories of armored warfare that had served them well in earlier campaigns. They assumed those theories would continue to work. They were wrong. The Americans, arriving late to the conflict, had the advantage of learning from everyone else's mistakes. They saw what worked and what didn't. They were willing to try approaches that seemed crazy to traditionalists. Some of those experiments failed, but the M18 Hellcat succeeded beyond anyone's expectations. In the end, the Hellcat teaches us that strength comes in many forms. Sometimes the strongest competitor isn't the one with the most armor or the biggest gun. Sometimes it's the one who refuses to fight on the enemy's terms, who uses speed and intelligence to turn every engagement into an ambush, who survives not by absorbing punishment, but by never being where the enemy expects. These lessons apply far beyond military history. In business, in technology, in life itself, the principle remains the same. You don't have to be the biggest or the strongest to win. You just have to be the smartest and the fastest. The legacy of those 18-ton ghosts racing through the French countryside lives on every time someone challenges conventional wisdom and proves that there's a better way. Every time speed defeats power. Every time adaptability overcomes tradition. Every time a small, clever solution defeats a big, obvious one. The Hellcat's kill-to-loss ratio wasn't just a statistic. It was proof that the human spirit, ingenuity, courage, the willingness to risk everything on a better idea can overcome any material disadvantage. So when you hear about the great tanks of World War II, the Tiger, the Panther, the T-34, the Sherman, remember the Hellcat, the vehicle that most people have never heard of, the one that German intelligence officers laughed at when they first learned its specifications, the one that proved speed and brains can beat armor and guns every single time, if the crew has the skill and courage to make it work. The M18 Hellcat wasn't just a successful weapon. It was a declaration that the rules of warfare had changed, and the side that adapted fastest would inherit the future. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. November 12, 1942, Richmond, California. A cargo ship slides down the ways into San Francisco Bay, and the men watching know they've just witnessed something impossible. The SS Robert E. Peary is complete, functional, ready for war. 4 days, 15 hours, and 29 minutes ago, there was nothing but an empty slipway. Now there's a 10,000-ton vessel capable of carrying tanks, ammunition, food, and fuel across an ocean. The German naval intelligence officer who reads this report 3 weeks later will understand immediately what it means. Germany has already lost World War II. They just don't know it yet. This is the story of how a dam builder who'd never constructed a ship became the architect of German defeat, how welding torches proved more powerful than torpedoes, and how American industrial capacity, organized by a man who didn't know the rules, buried the Third Reich under an avalanche of steel faster than any submarine could sink it. The mathematics were brutal, elegant, and absolutely final. In 1940, Henry Kaiser was 58 years old and completely ignorant of shipbuilding. He'd made his fortune moving dirt and pouring concrete. Hoover Dam, Grand Coulee, Bonneville. Massive projects that required organizing thousands of workers, meeting impossible deadlines, and improvising solutions when traditional methods failed. He understood logistics, efficiency, and industrial-scale construction. Ships? He'd probably never been inside a working shipyard in his life. He certainly had never built one. When Britain desperately needed cargo vessels to survive German U-boat attacks, traditional shipbuilders were horrified that Kaiser even bid on the contracts. The established yards had proud histories, stretching back generations. Newport News, Bath Iron Works, New York Shipbuilding. These were craftsmen who'd learned their trade from their fathers. Master riveters who could work in darkness. Welders who knew every metallurgical trick. Foremen who could spot a structural flaw from 50 yards away just by looking at a hull's curve. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. They built ships the way ships had always been built. Slowly, carefully. From the keel upward, adding each section in sequence. Riveting thousands of metal plates together with pneumatic hammers and red-hot steel rivets. Each vessel took months, sometimes nearly a year. A Liberty ship, even using the simplified British design, averaged 230 days from keel to launch at traditional yards. That was simply how long proper shipbuilding required. You couldn't rush maritime construction. Quality took time. The sea punished shortcuts with death. Henry Kaiser looked at those numbers and asked one question. Why? Why does it take 230 days? Why do you need highly skilled craftsmen for every single task? Why can't you break the construction process into simple, repeatable steps that anyone can learn? The shipbuilders laughed. Some openly mocked him. You can't mass-produce ships like automobiles, one executive told him. Ships have to be watertight. They have to survive North Atlantic storms. Stick to your dams, Kaiser. Leave shipbuilding to people who actually know what they're doing. But the U.S. Maritime Commission was desperate. Vice Admiral Emory S. Land, a Navy man with decades of experience, didn't particularly like Kaiser. The man was brash, overconfident, made promises that seemed physically impossible. But Land was also a realist facing catastrophic numbers. German U-boats were sinking Allied merchant ships faster than all existing yards combined could possibly replace them. In 1940 alone, over 1,000 Allied vessels went to the bottom of the Atlantic. In 1941, the losses accelerated. Britain's lifeline was being cut. Traditional shipyards couldn't scale fast enough. They were already overwhelmed with naval contracts for destroyers, battleships, and aircraft carriers. America needed merchant ships by the thousands. Kaiser was offering to build them. Land gave him contracts not because he believed in Kaiser's wild promises, but because America was running out of options. Britain was dying. Without cargo ships, the island nation would starve before American soldiers ever reached European soil. Kaiser was awarded contracts to build shipyards in Richmond, California. Not one shipyard, seven. 7 massive facilities on San Francisco Bay, designed from scratch to operate like nothing the maritime world had ever seen. He hired Albert Kahn, the industrial architect who designed Ford's River Rouge plant. "Build me a shipyard that works like an assembly line," Kaiser told him. "I want ships to move through construction the way cars move through a factory." The traditional shipbuilders watched with malicious anticipation. This civilian was about to learn the most expensive lesson in industrial history. Ships weren't automobiles. You couldn't just apply factory logic to centuries of maritime tradition built on hard-won knowledge, paid for in drowned sailors. The sea would expose every shortcut. Welded hulls would crack in rough water under stress no riveted ship would fail to handle. Unskilled workers would make fatal errors. Kaiser's ships would sink. Men would die. The Navy would shut down his fraudulent operation, and the real shipbuilders could get back to doing things the proper way. Except Henry Kaiser didn't know he was supposed to fail. He broke every rule because he didn't know the rules existed. And that ignorance, combined with methodical engineering thinking, was about to change naval warfare forever. Richmond Shipyard No. 2 opened in December 1940. Within weeks, Kaiser had thrown out the traditional shipbuilding manual and replaced it with principles borrowed from dam construction and automobile manufacturing. Instead of building ships from the keel upward in a single dry dock, slowly adding each section in sequence over months, he created a parallel assembly process that would have seemed insane to any experienced naval architect. The hull was divided into prefabricated sections built separately across the massive yard. Bow units, stern assemblies, deck houses, double-bottom sections, engine rooms with machinery already installed. Hundreds of workers welded these enormous sections in separate buildings, working simultaneously on different parts of what would eventually become a single ship. Then, massive cranes, some of the largest in America, specially designed for this purpose, lifted the multi-ton sections and assembled them like puzzle pieces. It was audacious. It was unorthodox. It violated every principle of traditional naval architecture, and the old guard predicted utter disaster. Traditional shipbuilders used riveting exclusively. Teams of skilled workers heating rivets to red-hot temperatures, then hammering them into pre-drilled holes with pneumatic guns that shook entire hulls with their pneumatic thunder. It required years of training to rivet properly. You had to know the exact temperature too hot, and the rivet would be brittle, too cold, and it wouldn't form properly. You had to know the exact force, the precise angle, how to work in cramped spaces, how to coordinate with your team. A master riveter was an artist. Training took years. Kaiser looked at riveting and saw an inefficient bottleneck choking production. He used welding instead, arc welding, a relatively new technique for large-scale hull construction. You could train a competent welder in 6 weeks. Not a master welder capable of the most complex joints, but good enough for most structural tasks on a cargo ship that didn't need to withstand battleship-level stresses. The old guard was horrified. Welding is inherently inferior to PAF. Riveting, they insisted with the certainty of men who'd spent decades mastering their craft. The joints are weaker. Welded ships will develop stress cracks in rough seas that riveted ships would handle easily. This is dangerous, reckless, amateurish. Men will die because of Kaiser's arrogant ignorance of proper maritime engineering. Kaiser ignored them entirely. He had his engineers run the calculations with actual metallurgical data rather than traditional assumptions. Welded joints, when properly executed, were actually stronger than riveted joints. More importantly, they were more flexible, better able to handle the stress and flex of ocean swells. The traditional shipbuilders were operating from prejudice and conventional wisdom, not rigorous engineering data. Kaiser operated exclusively from data. He hired everyone the traditional yards wouldn't touch or couldn't get. Women, African Americans, Mexican Americans, people with physical disabilities, people who'd never seen a ship before in their lives, let alone built one. At peak production, Richmond employed 90,000 workers across the 7 yards. 40,000 of them were women. Rosie the Riveter wasn't just propaganda, she was real. Her name was Rosie Monroe, a riveter from Kentucky. There was Ella Madden, who set a record with 3,000 rivets in a single shift. Wendy the welder, whose real name was Janet Doyle, became famous for producing perfect welds under impossible deadlines and demanding conditions. There were grandmothers working alongside teenagers, former schoolteachers welding beside former farmhands, housewives who'd never held industrial equipment suddenly operating cutting torches, office workers becoming crane operators. These weren't skilled maritime craftsmen with decades of inherited knowledge. They were ordinary Americans who learned one specific task and performed it repeatedly with increasing speed and precision. Kaiser treated them exactly like Henry Ford treated assembly line workers. Break complex jobs into simple, discrete steps. Train intensively on that one step until it becomes automatic. Maximize efficiency through focused repetition. Perfect one task rather than attempting to master an entire complex craft. It was pure industrial logic applied to shipbuilding. The traditionalists said it couldn't work, the mathematics said otherwise, and the mathematics were correct. The traditional shipyards watched Kaiser's construction times with growing disbelief that turned to grudging respect and eventually to alarm. 230 days became 180 days, then 120, then 90, then 60. By mid-1942, Richmond was launching a Liberty ship every 45 days on average. The old shipbuilders stopped laughing. They stopped mocking. They started paying very close attention because something genuinely impossible was happening in California. Some traditional yards tried to copy Kaiser's methods. Others clung stubbornly to their centuries of tradition. But none could match his relentless pace. Then came the competition that would create the record that stands to this day. Kaiser's Portland, Oregon yard built a ship in 10 days. An astonishing, almost unbelievable record that made headlines nationwide. Richmond Yard No. 2 took it personally. Workers and management alike wanted that record back. They pushed harder. Foremen optimized every single step of the process. Prefabrication was perfected to the minute. Crane operators practiced their precision lifts until they could place 40-ton sections with inch-perfect accuracy, while other crews were already preparing to weld them in place. November 8, 1942, Richmond Shipyard No. 2. The keel for the SS Robert E. Peary was laid at exactly 12:01 a.m. What followed was a choreographed ballet of industrial precision the world had never witnessed before. Prefabricated sections arrived on precisely calculated schedules like clockwork. They were already complete piping installed, wiring run through conduits, fixtures attached, even painted. Massive cranes swung them into position with practiced efficiency. Welders swarmed over the growing hull in coordinated shifts that never stopped. Day shift melted into night shift, melted seamlessly into day shift again. The work never paused. Meals were brought directly to workers at their stations, so they didn't waste minutes walking to and from mess halls. Inspectors followed immediately behind welders, checking every joint with X-ray equipment and visual inspection. The ship grew before the eyes of journalists, Maritime Commission officials, and competing shipyard managers who'd come to witness what they still half believed was impossible. Hour by hour, a cargo ship took shape from scattered steel sections. The Peary required 250,000 individual parts weighing approximately 14 million pounds total. Every single component had to arrive on schedule, be installed correctly, and integrate perfectly with adjacent sections. One missing bolt, one misaligned weld, one incorrectly sized pipe fitting could cascade into delays. But Kaiser's system worked with mechanical precision. Supply chains delivered materials exactly when needed. Workers knew their specific tasks so thoroughly they could execute them almost automatically. The assembly process flowed like water. 4 days, 15 hours, and 29 minutes after the keel was laid, the SS Robert E. Peary slid down the ways into San Francisco Bay, a complete functional 10,000-ton cargo ship, built faster than most families could remodel a kitchen, faster than most people could build a large garden shed. Newsreels captured the launch for theaters nationwide. Journalists swarmed Kaiser, asking how it was even physically possible. "We didn't know it was impossible." Kaiser smiled that confident smile that drove traditional engineers to fury. "So we did it anyway." The record still stands today. Over 80 years later, no shipyard anywhere in the world has ever built a comparable vessel faster. Not in peacetime, not in wartime. Not with modern equipment and computer-aided design. The record is untouchable because nobody needs to build ships that fast anymore. Kaiser proved it was possible. That was enough. But here's what truly mattered to the war's outcome. The Peary wasn't a stunt. It wasn't a one-off publicity trick, though it certainly served that propaganda purpose brilliantly. It was proof of concept. Richmond Shipyard's average construction time dropped to 42 days after that demonstration. 42 days from keel to launch. Traditional yards still needed 6 months. Kaiser was building ships 5 times faster than the world's experts had confidently stated was the absolute physical limit of possibility. And he wasn't building a few demonstration vessels. He was building hundreds. By 1943, his 7 yards combined were launching 3 complete ships per day. 3 cargo vessels every single day. Do the mathematics. That's 90 ships per month. Over 1,000 ships per year from Kaiser's operations alone, and there were other yards using his methods. The numbers were staggering if you were planning Allied logistics. They were absolutely terrifying if you were coordinating German U-boat operations. Kapitän zur See Ernst Hoffmann commanded U-boat operations in the Atlantic from his headquarters in Lorient, France. His job was to coordinate the wolf packs, analyze convoy routes, direct submarines to intercept points, and maximize Allied shipping losses. He worked with maps covered in pins, intelligence reports, and mathematical projections. Every day, updates arrived. Another convoy sighted, another merchant ship torpedoed, another U-boat returning to port with empty tubes, needing weeks of resupply before it could hunt again. In 1941 and early 1942, the strategy had worked brilliantly. German U-boats were sinking Allied ships significantly faster than they could be replaced. The numbers looked genuinely encouraging from the German perspective. January 1942, 62 Allied ships sunk, 327,000 tons sent to the bottom. March 1942, 95 ships, 534,000 tons. The United States had just entered the war, and their coastal waters were essentially unprotected. U-boats operated with near impunity off New York, Florida, the Gulf of Mexico, sometimes sinking tankers within sight of American beaches while civilians watched the explosions from shore. The Americans called it the second happy time for German submariners. Hoffman's superiors in Berlin were celebrating. The United States was losing the Battle of the Atlantic before American industrial mobilization could even begin properly. Then something changed in the numbers that Hoffman tracked obsessively. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1942, Hoffman noticed something deeply disturbing in the convoy intelligence reports. The convoys weren't getting smaller or less frequent. They were getting larger. His U-boats were still finding targets, still sinking ships at roughly the same rate per patrol. The individual U-boat effectiveness hadn't declined, but for every merchant vessel sent to the bottom, 3 more appeared in the next convoy sailing from American ports. Where were they coming from? The intelligence reports from the Abwehr landed on his desk in January 1943. He read them twice, then a third time, then sat motionless at his desk, doing calculations in his head. American shipyards had produced 746 new cargo vessels in 1942. Not repairs, not conversions of existing hulls, not refitted passenger ships. Brand new vessels, built from the keel upward. 746 in a single year. Hoffman knew the comparison numbers by heart because strategic planning was his specialty. Germany's entire merchant fleet at the start of the war had been 2,500 ships, accumulated over decades of normal peacetime construction. America had built a third of that total in 1 year, and the projections for 1943 were catastrophically worse from the German perspective. Expected American production: 1,200 new cargo ships, 1,200. In 1 year, Hoffman sat at his desk and performed the mathematical calculation that would haunt him for the rest of his life, and that he'd later recount to Allied interrogators. A U-boat on an exceptionally successful patrol with favorable conditions and weak convoy protection might sink 4 or 5 vessels. Then it had to return to port for weeks to rearm, resupply, repair any damage, and give the crew rest before the next patrol. The crews needed psychological recovery time as well. The stress of submarine warfare was brutal, with constant fear of depth charges, claustrophobic conditions, and the knowledge that if your boat was hit, drowning was almost certain. Germany had roughly 400 U-boats operational at any given time across all theatres: Atlantic, Mediterranean, Indian Ocean, but only a fraction could be at sea simultaneously. Others were in port refitting, or in transit, or undergoing repairs, or serving as training vessels. On average, perhaps 120 U-boats were actively hunting at any given moment. Even if every single U-boat sank 5 ships per patrol, which was wildly, absurdly optimistic, that would be 2,000 ships per year maximum. America alone was building 1,200. Britain was still building ships despite the bombing. Canada was building ships. The mathematics didn't work. Germany would need to sink more ships than America could build just to break even, just to maintain the status quo. But America was building them faster than U-boats could possibly sink them. The equation was simple, brutal, and horrifying in its finality. It wasn't even close to a fair fight. The report on the Richmond shipyards made the strategic situation exponentially worse. One facility, just one among many American yards, was building 3 ships daily. Average construction time, 42 days. Record construction time, 4 days, 15 hours, 29 minutes. It seemed like enemy propaganda designed to demoralize German forces. It seemed physically impossible. Hoffman consulted with German naval architects, showing them the intelligence data. They ran their own independent calculations, checking and rechecking the numbers. It's theoretically possible, one engineer finally admitted reluctantly, but only with massive resources. You'd need tens of thousands of workers, uninterrupted supply chains bringing steel and components, unlimited raw materials, advanced fabrication equipment. Perfect logistical coordination, and most importantly, no fear of bombing disrupting everything. Germany didn't have tens of thousands of spare workers. Every able-bodied German was already in a uniform or in a factory producing weapons. Germany didn't have uninterrupted supply chains. The Ruhr industrial region was under constant Allied bombing. Rail lines were being destroyed faster than they could be repaired. Factories were operating at partial capacity, constantly moving equipment underground to escape bombardment. Germany didn't have unlimited resources. Germany was fighting on three fronts. Simultaneously, the Eastern Front against the Soviets consuming men and materiel at horrifying rates, North Africa against British and American forces, and defending occupied Europe against partisan resistance and increasingly devastating Allied bombing raids. Every resource was stretched impossibly thin. American factories, by contrast, were completely untouched by war. 3,000 miles from the nearest German bomber, well beyond the range of any possible attack, they had access to unlimited steel, aluminum, rubber and copper from mines across the continent. They had a workforce of millions, including women and minorities previously excluded from industrial work, suddenly unleashed as productive capacity. They had an economy operating at full wartime capacity with zero fear of bombing raids, no partisan sabotage, no resource shortages forcing production compromises. Hoffman's analysts created production projection curves, plotting them carefully on graph paper. The lines crossed in late 1943. By the end of that year, America would have more total cargo capacity than it had lost to U-boats since the war began, plus sufficient additional capacity to overwhelm anything Germany could possibly sink going forward. The U-boats weren't losing individual tactical battles. Many patrols were still successful. They simply couldn't win the strategic war. It was mathematical certainty, backed by industrial capacity, that Germany had no possible counter for. He drafted a careful report to Admiral Karl Dönitz, commander of the U-boat fleet, the man known as the Lion. In Nazi Germany, pessimistic military reports could be interpreted as defeatism, which was effectively a death sentence. Officers had been executed for less. Hoffman chose his words with extreme care. "Current strategy appears unsustainable," he wrote. "Enemy production capacity exceeds our destruction capacity by a factor of 3 to 1, and this disparity is increasing monthly. Recommend strategic reassessment of Atlantic operations." The report was forwarded through proper channels to Berlin, to Dönitz's headquarters. Dönitz read it and understood the implications immediately. He was a U-boat commander himself, a veteran of the Great War who'd spent time underwater. He understood tonnage, calculations, logistics, and attrition rates better than almost anyone in the German military. But what realistic options existed? The U-boat fleet was Germany's only weapon capable of striking at Allied logistics directly. To abandon the Atlantic campaign was to concede defeat, to allow unlimited supply shipments to Britain, to admit that Germany couldn't prevent American industrial might from crossing the ocean and eventually crushing the Third Reich. So they continued fighting a battle they'd mathematically already lost. Orders went out to U-boat commanders. Sink more ships, target high-value tankers carrying fuel, prioritize cargo vessels over warships, accept higher risks. But the fundamental mathematics didn't change. They couldn't change. Industrial capacity was industrial capacity. You couldn't sink mathematics with torpedoes. By mid-1943, the mathematics became undeniably visible in blood and wreckage. U-boat losses spiked dramatically. Allied convoy protection had improved with terrifying effectiveness. Radar that could detect surfaced submarines in complete darkness and fog. Sonar that could track them underwater with increasing precision. Escort carriers providing constant air cover in mid-ocean areas that had previously been safe hunting grounds called the Atlantic Gap. Long-range patrol aircraft like the B-24 Liberator, closing that gap entirely. May 1943. 41 U-boats sunk in a single month, nearly 10% of the entire operational fleet destroyed in 30 days. Dönitz called it Black May, and briefly withdrew the U-boat fleet from the North Atlantic entirely to regroup and develop new tactics. But Hoffmann knew the real defeat wasn't tactical. It wasn't about radar effectiveness or convoy protection or air cover, though those all mattered. The real defeat was industrial. Germany had lost an industrial war to an opponent with 10 times their production capacity and zero vulnerability to counterattack. Every U-boat took 10 months to build with skilled workers, precision engineering, and complex systems. Submarines required extraordinary manufacturing quality. Any flaw could be fatal at depth. Germany would produce 1,156 U-boats during the entire war, a monumental effort representing the largest submarine fleet in history and an enormous investment of resources. America produced 2,710 Liberty ships alone, just one class of merchant vessel, plus hundreds of victory ships, an improved design, plus tankers, plus escort carriers that hunted submarines, plus destroyer escorts, plus the ships Britain was building, plus Canada, plus Australia. The disparity was cosmic in scale. One side was fighting with metaphorical sticks and stones. The other had unlocked industrial power at a scale previously unimaginable in human history. Hoffmann sat in his bunker overlooking the U-boat pens at Lorient and performed the final calculation. At current rates, by 1945, America would have 5,000 new cargo ships. Germany would have sunk perhaps 2,000 Allied vessels total across the entire war, counting all theatres. The Allies would still have more ships than they'd started with. Plus Britain's existing fleet, plus captured Italian vessels, plus captured French vessels, plus Norwegian, Dutch, and Belgian ships seized when those countries fell. The Atlantic wasn't a battle anymore. It was a slow-motion execution by mathematics, an industrial strangulation where the outcome had been determined before most of the fighting even occurred. And the man executing Germany through superior logistics had never built a ship before 1940. The dam builder had defeated the German Navy. The final numbers tell the complete, merciless story. Kaiser's 7 shipyards produced 1,490 vessels during World War II, 27% of all ships ordered by the US. Maritime Commission. Total American Liberty ship production across all yards using his revolutionary methods. 2,710 vessels. Overall cargo ships of all types across all wartime programs. 5,777 vessels. Plus hundreds of warships, escort carriers that hunted U-boats, and destroyers that protected convoys. The entire Liberty ship program cost $13 billion in 1940s currency, roughly $200 billion in today's money when adjusted for inflation. It was the most expensive single industrial program in human history at that point, dwarfing even the Manhattan Project's cost. But it worked with devastating effectiveness. By 1944, Allied shipping tonnage exceeded pre-war levels despite 4 continuous years of losses to submarines, mines, surface raiders, and aircraft. The U-boat threat was contained, not defeated through superior naval tactics or better convoy strategies, but defeated through superior mathematics. Germany simply couldn't sink ships fast enough to matter anymore. Traditional shipbuilders had insisted Kaiser's methods would fail catastrophically. They were wrong about almost everything. Welded ships proved more durable than riveted ones in most conditions. The flexible welded joints actually handled stress and flex better than rigid rivets, contrary to centuries of maritime conventional wisdom. Yes, some Liberty ships did experience catastrophic brittle fracture failures. In cold water ships literally broke in half, but these were design flaws that were quickly corrected, not fundamental failures of welding technology. Of the 2,710 Liberty ships built, only 200 were lost to enemy action. Less than 8% losses. That's an extraordinary survival rate for merchant vessels operating in wartime conditions in submarine-infested waters. Assembly line production delivered consistent quality at unprecedented scale. Workers, trained in weeks, performed as well as craftsmen trained for years on the specific tasks that mattered for wartime construction. The amateurs had revolutionized an ancient industry that had resisted significant change for centuries. After the war, global shipbuilding adopted Kaiser's methods wholesale. Japan built their entire post-war shipping industry on assembly line principles learned from studying American wartime construction. South Korea did the same decades later when building their shipbuilding industry. Modern shipyards from China to Finland use prefabrication and modular construction as standard practice worldwide. The techniques Kaiser pioneered in Richmond between 1940 and 1945 are now simply how ships are built everywhere. The revolutionary became ordinary, the impossible became standard procedure. 2 Liberty ships still exist as operating museums. The SS John W. Brown in Baltimore, Maryland. The SS Jeremiah O'Brien in San Francisco, California. Both occasionally go to sea, maintained by dedicated volunteers. 80 years old and still functional. They could still make the crossing to Europe if absolutely needed, though they'd be painfully slow by modern standards. A living testament to the structural quality of Kaiser's supposedly inferior mass-produced vessels. The ships the experts confidently predicted would crack and sink have outlasted nearly all of their critics. Henry Kaiser went on to an extraordinary post-war career that proved his wartime success wasn't a lucky fluke. He founded Kaiser Permanente, one of America's largest healthcare systems. Applying the same organizational principles make quality services accessible through efficient systems and massive scale. He built Kaiser Aluminum, Kaiser Steel, Kaiser Cement. Everything he touched seemed to turn to industrial gold. But his greatest achievement remained those ships, and what they proved about innovation, determination, and the power of questioning conventional and wisdom. He'd proven a fundamental truth about innovation that resonates far beyond shipbuilding. Unconventional thinking could defeat conventional wisdom when backed by rigorous engineering and relentless execution. An outsider could revolutionize an established industry precisely because he wasn't imprisoned by its traditional assumptions and rules that weren't really rules at all. Assembly line principles, properly applied with intelligent adaptation, could work on anything, even complex products like ships that had been built essentially the same way for thousands of years. For Ernst Hoffmann, the war ended in defeat, exactly as he'd predicted in 1943 when he first read those impossible production numbers. He survived, which was more than most U-boat officers could claim. 30,000 German submariners died during the war, 75% of all men who served in U-boats, the highest casualty rate of any military service in any nation. Hoffmann was interrogated by Allied naval intelligence officers in 1945. They were particularly interested in when German command had known they'd lost the Atlantic. "When did you realize?" an American officer asked directly. Hoffmann thought for a long moment, remembering the intelligence reports, the impossible numbers, the calculations that refused to work no matter how many times he ran them. He finally said, "When we realized American production had exceeded our ability to sink ships. The intelligence reports on your shipyards, the Liberty ship program specifically, that was when we knew with absolute certainty. Everything after was just mathematics playing out. We were fighting an equation we couldn't solve." The American officer nodded, taking careful notes. "What would you have done differently with hindsight?" Hoffmann laughed bitterly, a hollow sound without humor. "Differently?" There was nothing to do differently. You can't fight industrial capacity with willpower alone. You can't sink mathematics with torpedoes. We lost the moment your Henry Kaiser figured out how to build ships like automobiles. The rest was inevitable. We were doomed from the moment he started welding instead of riveting. The Battle of the Atlantic killed 72,200 Allied sailors and merchant mariners. 30,000 German U-boat crew died in their steel coffins beneath the waves. Thousands of ships went to the bottom. The ocean floor from the Gulf of Mexico to the Norwegian Sea is permanently littered with wrecks from that brutal struggle. But the ultimate outcome was decided not primarily by those battles, not by tactical brilliance or individual courage, but in Richmond, California, where workers who'd never seen the ocean built ships faster than anyone thought humanly possible. Where a dam builder looked at centuries of tradition and asked one devastatingly simple question. Why? And where the answer to that question changed the course of history and demonstrated that in industrial warfare, innovation and production capacity matter more than traditional excellence. The SS Robert E. Peary, the ship built in 4 days and 15 hours, made 6 successful wartime voyages. She carried 11,000 tons of cargo to Mediterranean and Pacific theatres, surviving dangerous waters where many sister ships were lost. She survived the war without serious damage, which was itself remarkable given the casualty rates. She was finally scrapped in 1963, 21 years after her record-breaking launch, having served well beyond her original 5-year design life. The record she set on November 12, 1942, will likely never be broken, not because modern shipyards couldn't replicate it with current technology and computer-aided design, but because nobody needs to. Henry Kaiser proved it was possible. That was sufficient. The point was made. And in proving it was possible, he proved something far more important than a construction record. In industrial total warfare, innovation matters more than tradition. Speed matters more than individual perfection. Volume matters more than artisanal quality. And sometimes the absolute best person to revolutionize an industry is someone who doesn't know the rules, who doesn't respect the conventional wisdom, who doesn't understand why something supposedly can't be done. Someone who looks at impossible and sees merely a challenge instead of an insurmountable barrier. Someone who asks, why not, when everyone else says, because that's how it's always been done. Kaiser was that person. His ships won a war through logistics rather than firepower. His methods changed a global industry forever. And his legacy is every cargo ship sailing every ocean today, built using techniques he pioneered, in yards organized using principles he established, by workers trained using methods he invented and proved effective, under the most demanding conditions imaginable. The amateur who revolutionized shipbuilding, the outsider who defeated centuries of maritime tradition, the dam builder who asked why and changed everything about how humanity builds ships. The Liberty ships weren't just cargo vessels carrying supplies. They were proof that in total war, the factory matters as much as the battlefield, that civilians with determination and systematic thinking can achieve what credentialed experts declare physically impossible. That innovation always eventually defeats tradition when backed by rigorous engineering and willingness to challenge assumptions. And that sometimes the most powerful weapon in total war isn't a bomb or a bullet or a torpedo. It's asking why not and systematically refusing to accept, because that's how we've always done it, as a legitimate answer to engineering problems that can be solved through logic and pites. Determination. Henry Kaiser asked that question in 1940. His answer buried the Third Reich under an avalanche of welded steel that crossed the Atlantic faster than U-boats could sink it. Mathematics defeated tradition. Industry defeated military might. Production defeated tactics. And a man who'd never built a ship proved that sometimes ignorance of limitations is the greatest competitive advantage possible, because it allows you to attempt what experts know cannot be done. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.